Hi there. You're listening to Sample Space, a podcast about topics in data science that deserve some extra attention. This week, I'm talking to Guillaume Lemaitre, and he's a colleague of mine, and he's well known for a few things. He's a Scikit-learn core maintainer, but he also worked on this project called Imbalanced-learn. It is a project that has lots of techniques, usually revolving around sampling, that might be able to help you if you're dealing with an imbalanced classification task. You can think of things like fraud. However, the project's been out for a while, and there's been some reflecting, and maybe we're at the point in time where we should rethink the Imbalanced-learn project. It's not like the techniques in that tool don't work, it's more that inside of Scikit-learn we might have better techniques at our disposal, and looking back, it might have also been the case that folks were just a little bit too optimistic when it came to resampling techniques. I'll be talking about some of the lessons that have been learned over the last 10 years, and I can definitely imagine if you're interested in imbalanced learning that this is a podcast you're interested in. Okay, good. Then, bonjour, Guillaume.
Hello.
Hi. So, for everyone who's listening, just so you know, I'm going to be interviewing my colleague today, Guillaume, and we are definitely colleagues, so there's going to be a bit of an informal conversation on that front. But Guillaume, I think the reason why I wanted to talk to you was because of this library called Imbalanced-learn. I could be wrong, but I think it's one of the more popular Scikit-learn plugins. Is that accurate to say still?
I think yes, or maybe the second one. I mean, I don't remember. This is maybe something about categorical data that was as well popular at some point.
Sure. But top five, right? Top five.
That's a good one. Yeah.
Yeah. So we're going to talk about this library that is in the top 5 most popular Scikit-learn plugins. It has tons and tons of downloads. And there's been some lessons learned, I think, is one way of putting it. Yes. So we're gonna get to that because I think it's an interesting story. But maybe a good introduction, okay, Imbalanced-learn, sounds like we're doing imbalanced stuff. How did that library got created? Because I think we have to go back in time just a little bit, right? For that one, for this story.
Yeah. I think the history is kind of nice because it explains why we are at that stage now. But so for the story is that I was doing a PhD in medical imaging where I was trying to detect on MRI images volumes that are cancerous versus volumes that are not cancerous. And in that case, usually what you have these imbalanced params because you have a lot of voxels which are not cancerous, hopefully, and only few of them are cancerous. And when I was doing this research, I went back to what should I do in the literature and what you need to apply as methods to tackle these params.
And one thing for context, when was this PhD? What time are we?
2016 or 16 or 17. So
right. Okay. So maybe there was some deep learning happening in the background, but some of the deep learning libraries was kind of new. We were Scikit-learn was definitely a ball that already was rolling, right? But it's still relatively early in the data science ecosystem.
Yeah, exactly. So at that time, deep learning was not a thing. When I finished my PhD, deep learning was a thing, and then I could throw away my PhD. More or less
more on that later.
But you learn stuff, so this is a nice part. And so to tackle that problem, I went outside and then looking at the literature, and one thing that was very popular and cited, and everybody was saying that's the state of the art, is what's called SMOTE. And when you're in PhD and that you do apply things, the first thing that you do is I'm using this. So first I moved from MATLAB to Python. Mm-hmm. I'm doing machine learning, and now I have these params. So people tell me I use SMOTE. So you just Google SMOTE in Python.
So when you say I use SMOTE, is it at academic conferences or how easy was it to find this paper? How did you actually find SMOTE? Is it a thing that was the norm kind of, or?
Yeah, because SMOTE was published I think, in GMLR, so Journal of Machine Learning Research. So which is a very, very good paper.
Right. So you knew that there was a thing called SMOTE. There was a paper about it. Maybe just for context, what is SMOTE? What does the algorithm describe there?
So the algorithm is, so you could somehow, it's a fancy random oversampling.
Okay. Right. So the premise is we've got an imbalanced data set. We got lots of zeros and only a few ones, but we want to predict the ones. Numeric stuff. Oh my God, how do we fix that? And then SMOTE says, well, there's a sampling trick. That's the gist of it, right?
Let's put as many zero as one, such that my classifier will pay attention to both classes during predicting, because somehow this is it seemed that my classifier with the default settings, and this is important for the future, seems to not predict basically the minority class. So let's find a trick, and I could like random oversample. Where Smooth is slightly smarter is that instead of just repeating samples from the minority class, it will just try to use the nearest neighbors to somehow find like the density via nearest neighbors and create sample where it makes sense. I mean, in that Euclidean space where it makes sense to create them.
Sure.
So somehow, that's more or less the trick there.
So it's not exactly like, oh, we're just going to sample more ones. There's a little bit more of a nuance there that tries to do something clever with the distribution. But I think the main trick, and correct me if I'm wrong, is still, oh, let's see if we can sample more ones such that the balance between ones and zeros is kind of equal. And hopefully that'll help my algorithm later not forget about the ones, because that's the thing you're afraid of. You're afraid that you're never going to predict fraud, because if you never predict fraud, you're still 99% accurate. Like that kind of story.
Yes, exactly. So that's the bottom line is these things, and then everything goes inside the implementation details of that algorithms.
Right. And are there lots of implementation details there, or is it what we just mentioned? Is that kind of the gist of it?
So there's this one, and then there's like so there's some fun part because at some point in these algorithms you find some neighbors, and from that neighbors you will pick up two neighbors, and you will generate one given an interpolation basically between those two. But the interesting part is if I have those two samples, the original paper just mentioned like you need to create a sample within the rectangle or like the hyperrectangle. Right. And in later papers, it said it should be on the segment.
Ah, interesting. Okay.
And then it's like, so I remember to have reached out to because we implement one way, and then I reach out to people of the original paper when we had this discussion, like what is the right way. And somehow this is just like purely empirical, and there's no justification what to do. And even like the original authors doesn't know.
Right. Exactly. So it's a situation. It's an algorithmic detail where this seems to have worked, so we kept it in. Kind of a
yes. But it's funny that this is changing. Like if you check like the original paper and take the anniversary paper like 10 years later, that's not the same algorithm. So you go from and already I mean, for me this is kind of fun. Like is there any theoretical background that should tell you like you shouldn't do this, or like, I mean, segment makes sense, the hyperplane doesn't make sense, at least for me, because like if I'm inside a Riemannian space, like okay, I can, that's a manifold. I mean, like the hyperplane is a manifold, so maybe that makes sense. Like the square, like the
yeah. So it's, like you're used to algorithms that come with lots of proofs before they come with an implementation, and this algorithm came with, well, we kind of did this, and there's no proofs, and that kind of felt. Is that the feeling?
Yeah, but the rock curve were nicer, or like, I mean, they were showing empirically some like evidence that it looks to work better. So that's the metrics.
I mean, the empirical argument is pretty good. Like if it works in practice, why worry about if it works in theory? I mean, there's something about that argument, that's defendable, I guess. But one thing about the Smo paper, because one thing we talked before, so there's like a detail here that I think we should mention. So you were doing your PhD starting in 2016. But this paper was from well before then, right? I think it was from 2002 is what I've written down here.
Yes, I think so, because I think like 2 years ago it was the 20th anniversary paper. So that could make sense.
Yeah. So this paper was around for like a while, and I think in my notes I've written down it's got like more than 30,000 citations. So it is safe to say this Smo paper thing, it's not a small deal. It's kind of a big deal, this one.
Yes, I mean, that's why I was really confident on I should use these things, because like that's the state of the art. This is like where you should go to solve like the problem that you have at hand. So that's why I started by that thing saying like, oh, probably I should like look at, is there any implementation in Python for that things.
And was this around you did your PhD at INRIA, I think, right?
No, I did my PhD in Girona, so Universidad de Girona, which is in Spain, and it was, I mean, between France and Spain, so in Catalonia, I should say. So Girona, and otherwise in a small lab in France.
Gotcha. But then one thing I wonder, so by this time, 2016, I mean, Scikit-learn was definitely like a thing. And then for your PhD, you kind of wanted to have techniques that are kind of similar to scikit-learn, I would say. But you also figured, okay, I want to do the Smote stuff. So was your first reaction then to reach out to the scikit-learn team and kind of go, hey, I want to do Smote stuff. How can I do this? Was that sort of the order of things, or was it a little bit different?
No, I was more shy than that. So the first thing is that I saw this Smote algorithm that somehow was not pretty compatible with scikit-learn, but I wanted to have stuff that go inside my pipeline, and I mean, like, that is compatible with scikit-learn. So this, I knew what to do and to already try to work on this package from someone else that have this Smote implementation and just like bring like the compatibility layers, because it's what I needed. So there I was not shy. I went there and started to do things and say, hey, do you want that? And then the person was, oh, that's cool. And then because I wanted to have a more empirical, let's say, experiment inside my PhD, I wanted to try different algorithms for resampling. So I started to implement like other methods compatible with scikit-learn, but competitors from Smote, and say, oh, actually, in my case, it looks like what improved my pipeline is this other algorithm whatsoever. So I wanted to make a kind of a benchmark there, and it's how I just implemented like new stuff.
So would I be correct in saying, like, okay, we've got the Smote thing that oversamples the minority class, but then your mind goes, oh, I want to also maybe undersample the majority class, and there's like a couple of these sort of quote unquote tricks that you had in your mind. You kind of wanted to compare them because you're doing your PhD. You want to try out more than one method. So you kind of wanted to have a library that has lots of these tricks, Smote being the main sort of player that you're going to go for initially. But you were eager to do that benchmark. Is this correct to say it this way?
Exactly, yeah. And I think the package was called at the beginning Smote something. I mean, you should check GitHub like long time ago. But it was really Smote. And is where we start to be happy with what we were doing and that we're really compatible. Then we say, probably we should rename it. I mean, because it's not Smote anymore. It's more than Smote, and it's where like Imbalanced-learn.
And that's where the name kind of came from. You were doing scikit-learn stuff on imbalanced situations, and therefore you first had the different library name, but then we finally get to the point called Imbalanced-learn, where you're bag of tricks for imbalanced stuff. That's the short story there.
Yeah. And it's where we start to contact people in Scikit-learn, because they launched at about the same time something called the Scikit-learn contrib, which were external contributions. So we moved the repo from a personal account of the original authors that make Smote to Scikit-learn contrib Imbalanced-learn, where it is nowadays. And it allows to move from, your toy library that was super cool to play with, to something like, actually now this is not toy anymore, and it's open to everyone to like. That's a signal like, come and play with us.
It's funny. It's kind of funny. Like there's this library that I maintain called Scikit-Lego that has all of my Scikit-learn tricks together with some other maintainers, of course. And I've just always kind of found it easier to just kind of host it on my own sort of name. But I was fully aware of the fact that it does come with a sort of cost, because if you can kind of host it not inside of Scikit-learn but kind of close to it, there is more confidence that it's going to be sort of maintained, and that sort of people with, not necessarily a PhD, but with like knowledge in numerical algorithms have had a look and confirmed that stuff actually converges and stuff, right? But so because you did that, I am kind of imply here that you were also thinking more about the long term for this project at that point, because you do that because it's more serious, right?
Yes, and because we got at that point we got, I think we wrote a paper about when we moved, and I think we have 4 authors on the paper. So somehow it's like, because we grow several people that were maintaining the things, then it was more logical, like, so let's make it more a community-based things, because actually we start to have people engaging with us.
Right. So someone says, I've got a pretty clever like Imbalanced-learn trick I might want to have.
Yes. Right? So do you want to have it as well? And I assume that when you go from personal to, let's say, a community organizations, you are not the only point of failure. So otherwise, like when it's on you, at least people might have the impression that you are the one, even if you are very open, because I'm sure that you are like this for Scikit-Lego. Even if you are very open to any contribution whatsoever, like the signal that this is not attached to a personal account, then people might just go easier, like go and start to engage maybe a bit easier there. But just some thinking there.
The thing that I remember from Scikit-Lego mostly is that I still do a bit of maintenance on it, but there's someone new called Francesco, and he's basically been doing more work than I am at this point. And that's great. It's just that when people go Scikit-Lego, they immediately go, "Oh, Vincent." And even though right now you kind of want to make sure that people also recognize Francesco, so there's a social dynamic downside, I guess, to sort of still having a project under your own name, because it is on my GitHub still, right? And I can imagine that sort of there's this acknowledgement scaling factor if you're just proper community based, right? That also comes as a benefit there, because it also makes it more welcoming, I guess, instead of it being focused on a single person. So, okay, we've established how this thing got made. That's great. There's a sort of implementation aspect of it that I figured I would discuss first. So, one interesting thing about the Imbalanced-learn is that it's technically not something that's 100% compatible with the Scikit-learn API, I think. And that's because we're doing resampling, right? So a normal Scikit-learn pipeline, it does the fit, it does the predict. But because we're sampling here, we are changing the data set X, so to say, that goes into the pipeline and the length of the data set. So there's a bit of a difference, I think it's fair to say there, right?
Yeah, so we cannot use the API with transform, for instance.
Yeah, so in Scikit-learn land, if you're transforming data, the number of rows should never change, and what you're doing is exactly not that.
Yes. So here we needed to extend the API and to come with something. I think at the beginning we call this resample, and then somehow we change over the time it changed. Now this is a fit sample.
Ah, okay. I remember it being resample actually, but it might be like a few years ago that I remember it vividly. Like, oh, the verb is resample, but I guess that changed then.
Yeah, the thing now is that you cannot decouple the fit and the sample because we want. So this is a constraint that we want to have with the pipeline as well, such that you cannot resample at prediction time because that's only at the fit time. So there's two things. So we came with a new, let's say, verb.
Right. Yeah, so it makes sense. So you can, so it's. I'm gonna make a bad language joke, but it does feel more fitting to only do it at fit time.
Yes.
Okay.
And so we had a different version, and then like somehow we just like get to a final like single method, and then we needed to iterate from the pipeline from Scikit-learn and to incorporate how to deal with a sampler. So we have a new type of estimator, which is a sampler, which have a base class, and even people can use a base class if they want to. The same way that you have a transformer mixing or like.
So in Scikit-Lego, we could put weird samplers if we wanted to. We could just inherit from the Imbalanced-learn one. So I think.
Yeah. But then you need to get as well our pipeline, which is the same Scikit-learn pipeline. It's just that we say, if you encounter a sampler during .fit of the pipeline, then you will call fit resample. And when you are predict time, you don't do anything.
Because you don't have to do any resampling whatsoever. I gotta ask, like, is there a use case to do resampling at predict time? Sounds like we're getting into exotic algorithm land when I say this, but I'm interested. Like the fact that you added that as a constraint suggests that there are actually approaches that do that.
It's just that you wanted to have it work properly, and such that people cannot do a fit and then sample another data set as well.
Right.
Because
okay.
the two are linked as well.
It's not the case that there were all these algorithm designers saying, please let me do this. And then you say, no, we got to add a constraint. It was more like, no, let's keep it simple, folks.
Yeah. So I assume that when we start at the beginning is that we were a Scikit-learn user, but like any good Scikit-learn user, we didn't know that pipeline was existing.
Right.
So we were doing stuff by hand, and it didn't come to your mind that you could do like weird stuff, like that you should constrain your API such that whenever this when this is a pipeline, you should not allow like exotic stuff. So, and I think that when we start to be compatible with things, we start to think of, gotcha. We didn't think about that things. I think it was more inside that in this order. Let's say.
I'm kind of curious about the timeline now, actually, because I remember a time when the pipeline API inside of Scikit-learn wasn't that popular yet. Like it took a while before that sort of became kind of more of a norm. Would that also be around the time that we're talking here? Was it 2017-ish that the pipeline thing really mattered? Or was it something like that existed well before then?
I don't know.
Okay.
I know that my first PR when I started at Syneria was to add caching in pipelines. So pipeline was already existing in 2018-ish.
Right.
And somehow it's because you have this. So when you want to be compatible, you need to pass the check of the estimators. So one is like I put you things inside the pipeline, and then I need to know how does it work. Is it compatible or not? So I assume that this is how we discover. I still thinking that, I mean, even if pipeline should be like super popular, and I hope that most of the people use it, I think this is still not the case. I mean, this is still like something that we try to make it popular. We try to say to people, try to not click data and use our things. But I mean,
yeah, it's a
usually
thing. It's a thing.
You say, hey, I can do everything on my own. I mean, I don't need that. I mean, that's what it is useful.
Yeah, it's funny you mentioned that. So I do remember teaching people the Scikit-learn API. I remember, I mean, this was like 5 years ago, easy. But I do remember showing people like the pipeline, like, oh, look, it's pretty easy because then you don't have to, there's no manual mistakes you can make anymore. And I do remember people sort of who've been using Scikit-learn for years look at the pipeline and kind of go like, oh, it's amazing. Why did I never look that? And I think the reason is that, oh, I know that I should use random forest because that's in all the academic books. Oh, I'll Google random forest and I find the Scikit-learn. Great. But if you don't know that pipeline is a term you should look for, you're not going to Google for it. I think that's the issue there.
Yeah, I agree. It's not the first thing that, I mean, usually you Google the thing that you need. You don't start to say chapter 1 of the documentations. And,
well, and also like it'd be pretty interesting if Google said, yeah, you're typing this, but I'm pretty sure you don't mean it.
Maybe LLMs.
Yeah, exactly. LLMs might at some point. Who knows? Okay, but a small sidetrack, and then we're going to come. So, because you're involved in the Scikit-learn now as well, I believe you're one of the core maintainers at this point. Was this also around the time that you were doing imbalanced learning, your PhD, that slowly but surely you got into the Scikit-learn thing, or was that kind of like a separate experience?
No, it's kind of all linked. So I was doing my PhD with Imbalanced-learn, and one day, so that's the fun part. I saw Gaël Varocco, which is one of the co-creators of Scikit-learn, speaking inside the conference.
Which one?
In Paris. So it was in Paris. It was a very small, like Frenchy things. At the time, we say, "Oh, I'm going there. I want to speak with the person there."
Sure. And, okay. So you looked at the brochure and went, "Okay, French conference. I'm going to you because Gaël is there."
Yes, I mean that was. And then I arrive, and then we start to speak. Oh, Gaël, and then I'm the person doing like Imbalanced-learn and stuff like that, and from there, I mean, like it went to maybe there's opportunity for like a postdoc.
Oh, right, because you're also thinking about like after your PhD, you might want to. You like this, so you're not so much interested in the MRI stuff, but the coding stuff was fun. So let's see if you can get close to Gaël and maybe do postdocs. That was kind of
So it's when I started basically at INRIA, I saw what real research should be. And I say, oh, I'm a much better engineer. And instead of doing like, I would pray that just focus on that because I have fun with this. And actually there's like there's better people doing research. So let's switch. And then, I got involved. I mean, I was doing like several stuff, but this is where I started to contribute to Scikit-learn itself and be paid to contribute.
INRIA had or still has a program for that, if I recall correctly, right? Like there was, I think there was a group that for years have been paid by INRIA, but a large chunk of what the group did was work on Scikit-learn directly, if I recall. Am I saying it correctly on this one?
It was this group. It was the group of Gaël that. So at the time, it was first we were employed as engineers within the research team, and part of our time were dedicated to open source and Scikit-learn then, or JobLib or stuff like that.
Sure.
And then we created the foundation have been created, and we joined the foundation, the INRIA Foundation, where we have a Scikit-learn consortium inside.
Gotcha.
And then this lead to probabl nowadays.
Sure. Then we're gonna do a big jump to the future on that one if we're gonna go there. But no, I do think it's nice to acknowledge that my impression is that INRIA has sponsored a good chunk of the Scikit-learn development. INRIA is an accurate statement.
Yes. They have really been supportive and understanding of and all of those type of things. I don't think that this is everywhere that these things would have happened.
No, like it seems to me like a pretty unique thing, and also Scikit-learn is a pretty unique success story in a lot of ways as well, because it does feel like kind of the library with all your tools. But it does feel like we should go back a little bit to Imbalanced-learn now, because part of the story is now clear. Like you did your PhD, and at some point you went closer to INRIA. But when you did more Scikit-learn stuff, but you still brought Imbalanced-learn with you. It became one of the more popular plugins, I think, at some point. And correct me if I'm wrong, but I can immediately imagine
banks probably kind of like it because fraud is like super imbalanced, right? Like that's kind of the use case. But I'm assuming by this time, like you're probably going to hear stories of people using the library as well, right?
Yes. Yeah, and we still like so I was maintaining and releasing to be compatible as well with Scikit-learn over times, adding a couple of new things and having feedback of people actually using it. And then so stars on GitHub doesn't mean always that much stuff, but it looked popular. And in the literature, so we published a paper to explain that we had an implementation of several methods. And the paper is as well cited for an academic paper. So that was super interesting. I mean,
so the thing that I think is interesting here is we're going to now go to the big contrast. So on paper, right, you've done the PhD in almost the perfect way. Like as a side effect of your PhD work in MRI stuff, you now have this immensely popular library that's well recognized. People want to use it in industry. Like on paper, there could not be a bigger success story than what has happened here, right? Like that's something I think I can say out loud.
Yeah, my ingenious way would be yes. And then, like if I'm a researcher, I need as well like academic papers. But at least like that's super nice to get outside of a PhD with something tangible that actually people use.
It's a pretty solid artifact, yeah.
That. I mean, people don't use whatever else I did during my PhD, but people use that. So that's
So I think we can both agree, like on paper, this really feels like, solid. Like not every PhD ends in something that's so used. I mean, there's millions of downloads at this point. Like that thing is like bananas in a way. But I think there's a little bit of regret now as well. I think it's sort of the other side of the coin we're going to talk about at this point in the conversation. Would I be correct in phrasing it that way? Like, hey, Imbalanced-learn is still around? Quote, 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 unfortunately, sometimes?
Kind of. I wouldn't say regrets. It's just that we learned stuff.
Sure.
Before to not know, you didn't know. So, but yeah, I agree. Now it is like, okay, but yeah. That.
Yeah. So there's been some reflections, and I mean, you've also talked about this at conferences. There's like the SpongeBob SquarePants meme of like, hey, you make a popular package, and then a few moments later, and then it's we regret.
Oops, sorry.
Yeah, there's a small bit of an oops. So okay, let's talk a little bit about the oops. So yeah, in short, how would you describe the oops that happened here?
The oops there is that for most of the cases that why Imbalanced-learn is used, it should not be used.
Yes. Okay. So
that like let's say the central idea is this. So then we can explain why. But
if I were to phrase it as the people like to use Imbalanced-learn to solve a problem, but there are better solutions these days. Like maybe that. Feeling, I guess.
No, there is the right solutions for that. And probably not the one in Imbalanced-learn.
Exactly. So Scikit-learn. So there's tools in Scikit-learn nowadays that actually solve it better than Imbalanced-learn. Yes, putting it that way. That's the which is an improvement for Scikit-learn definitely. But you do get into this awkward bit that you might have to unlearn some things to people now, which is a bit annoying.
Yes.
Okay. So what specifically then? So Imbalanced-learn, it has lots of resampling strategies, and the reason you do that is because you're afraid of overfitting on the majority class. How would you do that nowadays? What are the building blocks?
Yeah, probably the thing that... So I need to probably make a critiques of how did we end up inside that mess.
Sure.
So the first thing is, if you take the literature you show you empirically that this is working better. However, the literature has what we find out is that the literature probably didn't use the right metrics or didn't formalize the problem very well on how to assess it. And from there, they just turn around, finding new techniques that optimize something that actually is not the problem that they have at hand. So that's one of the first things there. So what does it mean in practice is when you take the decisions, fraud against not fraud, so you expect that your classifier will give you, let's say, hard decisions. And this, in Scikit-learn and in all the papers, in statistics, mainly what you do is, I could go from the probability, we cut as 0.5, and then if you're above 0.5, so 50% of chance to be the class, then you will be like positive, otherwise you will be negative. The problem is that because we have very low, we have these imbalance problems, actually the decision threshold that is at 0.5 shouldn't be placed there.
Right. So people should look. So actually, there's a hyperparameter there that we can play with, and people haven't been playing with that for a while, and that might be an
And
issue.
because, for instance, in Scikit-learn, you don't have the control on that parameters. And this is what the new things does, is that it gives you the control on that parameters.
I mean, theoretically, you can always do predict.probl and sort of do it manually afterwards, right?
Yes.
So that has always been an option, I guess. There's a thing inside of Scikit-learn that I made like years ago that also does some stuff like that. But now we've got tools that do this properly inside of Scikit-learn that also kind of automate this thing, right? Like that's the tune thresholder CV object comes to mind.
Tune, threshold, classifier, CV. Yes, that's
Yes,
very long, but I mean that's the idea. It's like you use consolidation inside to find this threshold that optimize a certain metric, so your business metric. Let's say.
Mm-hmm. So it's still an interesting conversation though, because I can imagine technically, right? We had those tools. I mean, we didn't have the tunes thresholder thing. Like that's something that's definitely kind of new. But I am kind of interested in sort of the back then. Okay, you read the SMODE paper, and because the SMODE paper was just out there, your gut reaction was, oh, let's implement that because it has lots of citations. Yes. Did that maybe also block you from just taking a step back and thinking, if I were to think on my own, like what would be an easy hack?
Yes, because
what made it hard to sort of think about this thresholding technique back then, I wonder?
Because for me, the thing is that I didn't relate that I needed a probabilistic classifier. So I didn't need to look at probability. I needed to take decisions.
Okay. Right. So it was so it was always yes, no, nothing in between.
Yeah. So then why to look at that thing? I mean, somehow I have predict that give me like these things, and then I just let's go on. I mean, I don't need to go back to the probability. And I assume that's one of the main issues there is like a lot of people are looking at I need to take the decisions and are only interested about the decision part. They are not. They are not thinking first like, oh, I need to look at the per plane and when I'm as a decision function or
distributions and yeah.
And I think this is one of the issues of the paper. They only, when I say the problem is not well formalized, they only look at the decision metrics that are derived from the confusion matrix. So you already threshold it. But we forgot to tell you, how did you threshold that things? So somehow we already removed, like we put a constraint. So now you are inside that setting that everything is constrained and you have those metrics. So somehow we are just playing on, can I change my data a little bit such that it has an impact on my metric? And somehow it was like, oh, pray, you don't want to change your data.
Yeah, but then it sounds like, oh, we've got this definition of the problem, and and given that definition, we're going to work on software. But you're never sort of doubting, oh, does that definition actually make sense? Kind of in that sort of space, maybe.
Yeah, because the first thing is like, so when you study those type of things is, and moreover, I'm not doing mathematics. So I was more of like an empirical scientist, like searching things. So somehow is like, I'm not going into the proof things because if somebody else went into the proof, so already this part should be, I go that this is true.
Yeah, hands off there.
Yeah, hands off there. And then it's coming like, oh, I have a new topic that I didn't know anything about it. And then to be like able to criticize or to be critical about like whatever is written, you need experience. Yeah. And when you write, you study the thing, say, oh, that's look good. I mean, they show a figure that, so let's implement it because that's the only thing that I'm able to do because I don't have enough step back. And I assume why nowadays we say, oh, actually, oops, we did a mistake is because we were able to step back and start to, ping inside some area that say, oh, actually, there's like fishy stuff there. Why is it always like this?
It's kind of like teaching someone list comprehensions in Python, let's say, and then you review their code a week later and everything is a list comprehension. And that's kind of fine because I just learned about list comprehensions. But the whole point of learning about list comprehensions is at some point you also learn not to use them. But you need experience in order to give yourself the permission to sort of rethink some of those things. Yeah.
The famous hammer and nails.
Yes. Okay, interesting. Okay, so one theme I'm hearing is like, okay, so instead of doing the resampling thing, I guess we can do a little bit of calibration. That's sort of a theme that I'm kind of hearing then, right? We can kind of think a little bit more critically about the business application and maybe have more of a field day with that instead of just saying threshold 0.5 all the time. I'm still kind of wondering a little bit, like at some point you made the decision to add some of those tools to Scikit-learn core, I think, and these sort of tools are not added to Imbalanced-learn at the moment, if I'm not mistaken, right?
What type of tools?
Well, so when you say like, oh, if you're doing something with imbalanced data, we can do stuff with calibrations now. Like you don't have to do the resampling thing because it's called. Because I'm asking this because it's called Imbalanced-learn, not resample-learn, right? Because Imbalanced-learn, the name implies like, oh, these are the tools you need to do imbalanced learning.
Yes. So first thing is because like when we speak about change result classifier, we implemented inside the last release of Scikit-learn. So somehow it's not that it's too early, but we need to have more documentation in Scikit-learn that documents basically all the shortcomings that I mentioned. Like we need to explain to you didactically that, look, you have probabilities, look, you have this, and if you want to have good probabilities, you need to be calibrated. If you have that, then you can translate into a consensus-sensitive params, and then you need to have your business metric, and then the effect as well of what's the effect of sample weight, what's the effect of class weight that already exists in Scikit-learn. And when that we explain that in Scikit-learn, what I would like really is to go back to Imbalanced-learn and say, by the way, we have all those methods, but probably you don't want to use them. Look at that documentation there. And then say, because there's still a part that the library would be used. So first, we have the algorithms, they are there. I mean, probably we not throw them away. But then we should be more didactic inside the documentation to explain when can you use them. So for instance, you could use some of those like balanced random forest that just like speed up your training, but then give you uncalibrated classifier and then tell you, oh, go and look at Scikit-learn to recalibrate the classifier, or we could even have a step to recalibrate the classifier.
Yeah. So you might still use imbalance. Yeah. So if only for the education of it, like you can still do benchmarking. That can be a useful exercise, right? So you can sort of do that exercise. But even if you have something made in Imbalanced-learn, you can still tell people like, okay, the probabilities might not be super well calibrated, but you can do it in the Scikit-learn now. So there might still be some sort of empirical moment when you combine something from Imbalanced-learn with Scikit-learn, and that ends up being the best. Like that's still possible.
Yeah, and I think that Imbalanced-learn could have a super great impact on explaining that basically somebody like me, like 10 years ago, go and read the paper of Smoot and check like, oh, I want to use Smoot now. Get to the Imbalanced-learn thing and just start to read, and then we tell you, wait, the paper there was wrong.
Yeah, right.
And then the paper will never. So what was wrong? I mean that the problematic is not as easy as what is described there. And then we give you all the descriptions. And while we cannot change an article from 20 years ago, we can do software and documentation, which is like evolving over time. So I think this is where like we can have an impact. So probably we will not bring tools from Scikit-learn to do imbalanced learning. This is more like we can recognize part and send people to Scikit-learn when it comes like, oh, you want to actually like, you have this param of Imbalanced-learn, which is, and you're inside that settings. So then you want to use this tool from there. And then we can explain you, if you were doing Smoot, for instance, or random sampling, we could explain to you what you were doing, because we are telling you, oh, actually, look, it's just that your threshold was like blocked and you are trying to move it by just resampling your data. So that's and just explain and be didactic about it and say, and probably it's not what you want, or you realize it's not what you want. I mean, people don't like to say that they were wrong. So somehow you have to as well explain what's the reason, and like that there is probably better way, and that you can go and
there's an interesting thing. So this is in my talk with Arturo, this also kind of came up. So Scikit-learn on one end wants to be kind of like your toolbox. It has lots of sort of tools in it. And I think it's still accurate to look at Scikit-learn that way. But if I think about a lot of the effort that people are doing right now, is not so much about the tools themselves, rather how you use them. Like the methodology, for example. Like it's very easy to fool yourself if you're running a benchmark. Please use these techniques to make sure that doesn't happen. Is that like a sort of a pivot that you also kind of notice now? It definitely feels like Scikit-learn is moving a little bit more in the, oh, we have to educate people more in the guide on this methodology stuff now, because otherwise people will just apply the algorithm the wrong way.
So after all, I've really like decided that he's very interesting about documentation. So for sure, for him, like that seems like one main thing. I think that in the past, Scikit-learn was recognized to have a good documentation even from the start.
Mm-hmm.
One thing that is sure is that some of the examples, for instance, we always found like, oh, actually, this example today, we can throw it away because it just show like how to use PCA. But we wrote just like, it's code, it's not,
Mm-hmm.
there's no explanation. And we realized that, yeah, one thing that is super important is to be more and more didactic in
The context and like
the
that sort
context
of stuff.
and how you use that tool. It's not anymore just like, oh, look at this shiny method, and then like when you call this fit transform, like magic happen, and then you get like new feature that are like in smaller dimensions. I mean, that's so. I assume that yes, we got to realize like, and I think like when after you arrive, maybe this one of the time that we say because we're already looking at the MOOC and looking at those and say we need more of this. And for instance, one thing that we realize that we wouldn't need in Scikit-learn is to have more examples which are related to business. Like I'm trying to solve that problems. This is like everybody will like figure out that this is like what does it mean, how it is, and then like we show like what one specific techniques that does that. But like this is solving a problems because it's come back to, and again that's coming back to the first thing, like framing problem, framing a problem like the right way is sometimes to just define a good business metric and to go beyond the precision, recall, accuracy, and all of those. So if we show to people the mindset that you need to have as well to solve those, that's for me have like a very huge impact.
Yeah, so I was looking at the PyData Paris talks. Like Olivier had a really nice slide in his talk, which was about, oh, you want to do fraud detection. Well, okay, you can define it as a classification problem. That's kind of fine. But what you can also do is you can do a trick where you say, well, depending on the amount of money in the transaction, I'm just going to have a different threshold, which is completely different than the standard classification way of thinking about it. But it makes so much sense if you're talking about fraud, right? And you kind of want to have more of those examples where you kind of make something bespoke instead of just taking something off the shelf and just keep on calling it the same classification problem, so to say.
Yeah. So somehow we need to mention to people, like we need to document for data scientists to say that classification stop to a point, but your business analyst is interesting about operational decisions. And we need to bring you towards how do you go from this classification, so fraud, not fraud, to actually a real number, which is gain, and so not gain and pain, but gain and losses.
It's like business Bob comes walking into the data science department and like the data science people kind of go like, look, we there's way less fraud on the platform now. Business Bob will never go, sure, but what's the precision and recall then?
Yes, exactly.
Yeah.
He's interesting about the big numbers in red or green. That is plus or minus, like at the end of the month.
The chart line does go up or down. Like something like that would be more fitting in a way. But okay, if you were to sort of look back on everything now, because I think like how old is Imbalanced-learn at this point? 10 years ish.
A bit less, but yeah, let's say 10.
Sure. It does seem that some of the lessons learned here is the whole, well, it's definitely if you're learning new things, it makes sense to update the library, right? So, and it can be the case that a lesson can take 10 years. Like that's sometimes just the way it works, right? Are there other lessons you've learned looking back at all of this? Like I can also imagine it's just super hard to see stuff like this coming. Like, the whole point of doing a PhD is that you're there to learn. And yeah, I'm kind of wondering, like, any perspectives on all this now that you look back, thinking where you are now?
I would, so first, the interesting part, like you finish a PhD, then you have people reading your PhD. Nobody ever mentioned like, oh, there's something fishy there. That's the interesting part. I mean, like in the reviewing process. But then why it took us so it didn't took 10 years, but like why it took so many years? Because you could say, I mean, that's not that complex. You should have think about it. Usually when then this is easy to think. But one of the things is as well that we have so few people, for instance, in Scikit-learn, with so many topics, then somehow that topics we didn't work continuously on it. And it was like, I mean, how it started was like, oh, we should have some resampling stuff in Scikit-learn.
Right.
So we need to bring Imbalanced-learn in Scikit-learn. And somehow like, looking at those, and then like, and that was like the power of open source and collective thinking was that, hey, did you try that? And it's like, oh, wait, that's going sideways now. So why is this a problem? The problem is that this is like always longish, because you are not like, you do the maintenance and that little topic that go and then you and you go, this is like the chart that say what do you expect with like a straight line, and like the reality which is like bump everywhere. So
yeah, and I can also imagine as a maintainer, I mean, if you think about like some of the what are the pull like the issues that people have, the issue is probably more going to be like, oh, I think I can make this algorithm faster, and oh, that's interesting. As a maintainer, oh, my library to be faster. Let's invest in all of that. And you're typically not going to get an issue that goes, this entire library needs to be rethought because I have made the conclusive benchmark, right?
I got one person, I mean one group, which are people at Dataiku. So like the VP, the person the head of the R&D at the time came to me and say, "Did you ever like witness any improvement?" And I was like, "Oh, sure. I mean, I program the thing, so I'm sure that there is like." And now this is a good trend, by the way. So
Right.
and then like by discussing, so first, that's the first thing is like you are defensive on the thing that we bring you, and then like on discussing, and he was making some like overthink, and like look, is what we look at this and this and this, and then is where you try to say, oh, that's weird. So yeah, there's something that we overlooked.
Right. So you have to get to the, I should double check that feeling.
Yes. and then one that you check the double is how basically these things just build up. So if I would have to redo the thing, like if I need to make a retrospective, I would probably do exactly the same. I just wish that the time would be shorter, not 8 years. I mean, that we have solutions like much shorter. But I would like the same process, because it shows multiple things. So first is like I learned a lot of stuff. I developed, like, for instance, it's how I learn how to make a website for documentations, that to follow like all the standards that are imposed by Scikit-learn, that are new Python fix whatsoever. I mean, and then it teaches you as well that sometimes paper in research are wrong, and then you should like take a step back. So it just teaching you like so much stuff that making a mistake is actually good.
So it's interesting. So actually, that's maybe my conclusion when I hear all of this. So one thing I've learned from maintaining Scikit Lego is that I basically figured, let's just have a fun little library and we'll just put stuff in, and then the community can tell me what stuff works and what doesn't. The only thing I'm like, my main contribution here is that you don't have to implement any of these like widgets yourself. That's just kind of there. And if people then, if it then works, other people can pick it up. And as a result, some of these things eventually went to Scikit-learn. So we had quantile regression just a year or two earlier, or little examples like that. And it kind of feels like something similar happened here. It's just that it's a bit more drastic. Like basically I imagine pretty soon the docs will be updated on the Scikit-learn side of things, and then they're going to be updated on the Imbalanced-learn side of things. But the lessons of Imbalanced-learn are definitely inside of Scikit-learn now. That is kind of an interesting thing in the end.
Yeah. And I can imagine now someone that comes to the documentation afterwards and feel like, oh, those dummies. It's like, but you don't know the full story.
Sure. I mean,
that's
yeah, no, it's. I mean, there's also just so many details here. That's also kind of the thing they get right, and especially as like it's also a numeric library. So I can also imagine the situation where, as a library maintainer, you're really worried about like numeric stability, and those are all like super legitimate concerns. But yeah, it's super hard not to be distracted. That's also kind of the story, I suppose.
Yeah. I mean, there's like many aspects, and for instance, you were speaking about like numerics. I could say that think about the same. Like, for instance, you have a nice paper explaining how LBFGS is working, and then implementing it to be numerically stable. That's another story.
Yeah. Like you can have the math proof here, and then you go, sure, but floating point numbers. Right.
I cannot put out as many digits that you want.
Yeah. There's finite precision. Sorry. Yeah. Okay. That kind of leads me to like the final question I kind of wanted to ask in this sort of podcast, which is usually when I do a podcast episode, I try to come up with like a catchy name, but I also try to come up with a name that sort of isn't too clickbaity, does describe sort of the vibe of the conversation that we've had. And I'm kind of wondering what would be a good, like, if you had to summarize the lesson that could also be used for a podcast title, like that'd be nice to have. Like, what might it be? Like, if Imbalanced-learn is still around, ... Unfortunately, like, what would be a good title? If you think about it now.
I'm still, I'm unsure. Somehow it's like,
Because there are actually lessons. I think you could argue that it's been a good experiment in a lot of ways. It's just that we are now a bit more careful in promoting the package.
Yeah, so somehow for me it's like Imbalanced-learn and then like a big triangle, be cautious.
Why the big triangle? Is that
like so the warning sign, sign of like
right.
Be cautious about this. Only use it if you know what you do. But somehow we should tell you what you should be using it for. That's the main things.
So only use Imbalanced-learn if you know what you're doing. It's a bit long.
Yeah. You can say we lied to you during the past 10 years.
Maybe we need to take this one offline in Slack. I think we can probably come up with a good name. But so in one sense, in a lot of ways, you could look at the Imbalanced-learn as an experiment, and when you do that, it's kind of a success story. But if you look at Imbalanced-learn as like the final product, it's not a success story. Maybe that's the contrast, I suppose.
Yeah. I mean, there's other software that does that.
Sure. No, but I mean, it means like the final. Maybe that's the interesting conclusion. The final thing that needs to happen to Imbalanced-learn at this point is the docs really need to be updated.
Yes. And the code to disappear.
But that might be a nice title. So the docs of Imbalanced-learn really need to be updated, like what's really being emphasized, and why. Okay. Cool. No, that's a cool conclusion. Thanks for being on. If people want to talk to you about maybe more Imbalanced-learn conclusions and lessons that have been learned, I think you're still around on the GitHub and stuff. Like you're definitely still making.
Oh yeah, I'm definitely there. So usually what happens is that I'm monitoring for the release to be sure that we are compatible with Scikit-learn. So one thing that is very nice is that this package allows me to know if Scikit-learn breaks stuff for third-party library. So it's super useful. What is inside, not the method, but the package is useful. And then I still go and try. So at the time that I'm making the release, usually I make a pass on the issues. And for the moment, I don't think that we want to have new feature because right now it doesn't make really sense to add new things that are not the right things. Then in the future, we could think can we just repurpose a bit what we do and have other things linked to Imbalanced-learning. So, for instance, some ad hoc post-tuning or stuff like that. I mean, that could be But
the future of Imbalanced-learn, it's definitely going to be more of an experimental place than sort of a production place. Then that's kind of what I'm also hearing.
I mean, the new feature, yes. If people still want to use the old stuff, I mean, that will be there and maintain and.
We're not going to nuke the project and break everyone's bills. Yeah, no, that's not going to happen.
No, I don't want to have the bank going down just because that was wrong.
Yeah.
As in machine learning, it's all models are wrong, but some are useful. So here this is the same. It's maybe something was wrong.
Yeah, but it's still useful. Yeah,
it might have been useful, and it's just that you can do better.
Sure. True. All models are indeed always wrong. It's just that this is a subset, basically. Cool. Then if people have questions, definitely check out. I guess you're also on our Discord once in a while. So if people have questions, they can also reach out there. But then thanks for being on, and see you on GitHub, and I'll maybe talk to you on Slack about that name for this podcast episode. Think about that. Thanks for listening to this episode of Sample Space, and thanks in particular for making it all the way till the end. I really hope you're enjoying these podcasts that we're making here over at Probabl. If you're interested to see more, you can find the podcasts on your favorite podcast player, but you can also go to our YouTube channel. And if you're interested, you can also reach out to us on socials. You can find us on LinkedIn, but we also are getting more active on Blue Sky these days. And in particular, if you want to speak to me personally about maybe some guests I got to interview, you can also find me, as well as many of my colleagues, on our Discord. Go to discord.probabl.ai. You'll find us there, and feel free to give us any feedback you might have. I hope you enjoyed this episode, and see you again next time.